Buenos dias, mi amigos. So we're doing a little pre-lecture to our kinetics unit in that we are going to focus in on how we measure concentration of aqueous solutions. Now there's more than just these two ways, but as far as what's pertinent to what we'll be discussing, we're going to focus on molarity and molality. All right? And in this we'll really just be focusing on the math side of it. How do we calculate those numbers? All right? So molarity first. So what we want to understand about molarity is that it's expressed as a capital M, or you could express it as moles per liter. All right, and so molarity is probably our most common way of representing the concentration of an aqueous solution. Okay, and so the way we calculate it is it's the moles of solute divided by the liters of solution. All right, so quick vocab check, and we have discussed this before, okay, but the solute is what gets dissolved. Okay, the solvent is usually a liquid, but it's what dissolves the other substance. Okay, so in the case of salt water, for example, the salt would be the solute and the water would be the solvent. Okay, so you need to make sure you can differentiate those terms. And so when we're talking about moles of solute, we're talking about the mole value of the substance we're putting in to solution, which again, almost all of our solutions are going to be aqueous, so they don't necessarily have to be, but typically we're talking about aqueous solutions, and the solute is whatever we're putting into the water. The solvent is almost always going to be the water. Okay? Now, a solution is the mixture of solute and solvent. Okay, so solutions are typically clear. They sometimes have a color. So for example, when we dissolved copper sulfate in water back in that copper extraction lab, we got that clear blue liquid. That is a solution where the copper sulfate was the solute and the water was the solvent. Okay, but a solution. So when we want to calculate the molarity, we're talking about the moles of solute, okay, divided by the liters of solution. Okay, so how many liters of the mixture do we have, and how many moles of the solute are in that solution? All right, so again, we need to make sure you're getting good at converting in and out of moles, and an important mental conversion, because we're not always making an entire liter of a solution. In fact, when if you guys are going to make stuff for your own lab, for example, you'd typically be doing maybe a quarter of a liter, or 250 milliliters. All right. So often I might say the volume measurement in milliliters instead of liters. Right. So for example, if I say make 260 milliliters. Right, I want you to very quickly and without going through dimensional analysis, just make a mental conversion of 260 milliliters would be 0.26 liters. Okay, so decimals here, we move it 1, 2, 3 places, so 0.26 liters is how we express that when we go about doing the actual conversion. Okay, so moving forward, what's an example of this look like? Okay, so again, we're going to take this milliliter value. We're going to do our quick mental conversion, and that is 0.25 liters, right? So we're going to automatically convert that to liters by moving the decimal 3 places left. 1, 2, 3. Putting the decimal there, right? So 250 milliliters is the same as 0.25 liters, and that should be an automatic conversion we can make in our head. All right, so I'm going to take my value for my solute. This is my solute, right? So whatever we're putting into water is the solute. So in this case is HCl. So I have 25.43 grams of HCl. and N to 0.25 liters, okay, of solution. Okay, so that is grams per liter. Now, for molarity, remember we want moles of solute. So this is my solute in grams, right? I need to convert that to moles, right? So this is already in liters, so I don't have to go through that conversion process. So all I have to do is change my top value here from grams to moles, right? So if we were to pretend that 0.25 liters wasn't there, how would I convert that into moles? I would divide by the molar mass of HCl. All right. So if you use your periodic table, you find that the mass of one hydrogen and one chlorine added together is 36.46 grams of HCl and 1 mole HCl. All right. And then we can do a little cross canceling of units there. All right. Now I go 25.43 divided by 0.25 divided by 36.46, and I should get 2.8 molar HCl. All right, and remember the symbol for molarity is a capital M. Okay, and that's how we do a molarity calculation. Simply take the grams of your solute, convert that to moles, divide it by the volume of your solution in liters. And how do you go from milliliters to liters? You move the decimal 3 places to the left. So that should be an automatic thing for you. Not super difficult to convert things to molarity. After all we've been through with stoichiometry, you guys should find this refreshingly simple overall. All right. Now, moving forward, I promise not to make this lecture very long, and I'm not going to. Molality. Okay, very similar to it, and the numbers should be pretty darn close to molarity. It's just a slightly different way to express it. So molality, which gets a lowercase m symbol rather than a capital M, okay, or it can be expressed as moles per kilogram. And so we can use molality as a value for concentration, partly because it does not change, right? So molarity, liquids and most substances will change their volume with temperature. So if I have a hot solution versus a cold solution, I might have the same amount of solute, but if I heat it up, the volume increases, and that's actually going to change my molarity slightly. Whereas molality, which is a mass measurement, will stay constant regardless of temperature. So it is a more consistent way to express concentration, although less common. All right, and so the way we do molality is we take our moles of solute, and this time we just take the mass of our water. Okay, so in kilograms. All right, so grams to kilograms, we convert grams to kilograms the exact same way we convert milliliters to liters. You move the decimal 3 places to the left. So if I have 240 grams of water, right, I'd move my decimal 1, 2, 3 places to the left. That equals 0.24 kilograms of water. Okay, but we set it up exactly the same way, right? So you just take your grams of your solute, divided by kilograms of water, convert your grams over into moles. There's your molality, and that would be expressed, well, I should say molality, and lowercase m. Sorry about that. Typo, but I've already recorded this far. I ain't restarting. All right, is moles over kilograms rather than moles over liters, and that's the only difference. All right, molality, though, remember, is more consistent because changing the temperature won't change the mass of your material, but it could change the volume. So molarity can change slightly with changes in temperatures, whereas molality will stay the same. All right, and this lecture is going to remain under 10 minutes. So when you walk in tomorrow, hopefully you've got some notes with which we can use as I try to put you guys to work coming up with a procedure to make a concentration of a specified molarity. See if you can come out with the right procedure for that. All right. Peace.